All right, so in this video, we're going to learn how to solve systems of equations using elimination. So when you're solving systems of equations using elimination, the first thing you want to make sure of is that your x and y values and your constants are aligned. So in this equation, they're aligned up because we want to solve the problem vertically or up and down. All right. The next thing you want to look for is opposite coefficients. And so in this problem here, we do have opposite coefficients. Remember, coefficients are numbers in front of your variables. Okay. So in this case, we have a negative 2y and we have a positive 2y. Those are opposite coefficients because what we want when we combine them to be 0, to eliminate them. So let's try this first problem here. I'm just going to use a different color to distinguish my work from the problem. So I want to solve it vertically. Okay. So I'm going to add x plus 5x, that is 6x, negative 2 plus 2y, that cancels out. That gives us 0. That's what we want. We want to eliminate one of those variables so we can solve for the other one. So in this case, we're eliminating our y value first. So that is just 0. And I want to combine what's on the other side of my equal sign. That is negative 19 plus 1. And that's going to give me a negative 18. So now I'm just left with the one-step equation to solve for x. So I have 6x equals negative 18. So I simply divide by negative 6 to solve for x. Negative 18 divided by 6 is negative 3. All right. So we've gotten x equals negative 3. But remember, with the system of equations, your answer is always an ordered pair. All right. So we found our x value, but we want to find our y value. So we want to take our x value and plug it into one of these equations to solve for y. Doesn't matter which one you choose. I'm going to choose the second one because I have all positives. But again, it doesn't matter. So rewriting this, 5x plus 2y equals 1. X is negative 3. I'm going to plug in negative 3 for x to solve for y. So that's 5 times negative 3 plus 2y equals 1. So remember, if you have your coefficient next to your variable, that is multiplication. So when you plug it in, we're going to write parentheses because we want to multiply them. All right. So that is 5 times negative 3. Negative 15 plus 2y. Now we just left with a two-step equation. Adding 15. 2y equals 1 plus 15. That is 16. And dividing by 2, y equals 8. All right. And so I have my ordered pair here. My x value is negative 3. My y value is 8. And so I've solved this system of equations using elimination. All right, so let's try another problem. So again, we want to look for opposite coefficients. So in this problem, we notice we don't have any opposite coefficients, but we do have 2 of the same coefficients, so we can make them opposites by multiplying one of these equations by negative 1 to get opposite coefficients. All right, so right here I have a positive 4y and another positive 4y. I'm going to take this second equation, and again, it does not matter what equation that you pick, as long as you multiply one of them by a negative 1, so that way you could get opposite coefficients. So I'm just picking the second equation. And you have to multiply that number, or this negative 1, by everything, including what's on the other side of your equal sign. So let's do that. So negative 1 times negative 2 will give me 2x. Negative 1 times 4y will give me negative 4y. And negative 1 times 8 gives me negative 8. So I've multiplied everything by negative 1. Now I have a negative 4y. I'm just going to bring down that top equation. 3x plus 4y equals 18. So that way I have it all together. So now I have a new system of equations with my opposite coefficients. All right. So just like in the last problem, solve it vertically. 2x plus 3x, that is 5x. Negative 4 plus 4 cancels out, which is what we wanted. We wanted to eliminate it. And then negative 8 plus 18, that gives me 10. Got a one-step equation left. Divide by 5, x equals 2. All right, we found x. We need to find our y value. I could plug it into any one of these 4 equations. I'm going to actually just plug it into the first one there because I have all positives. All right. Again, it doesn't matter. You're going to get the same answer. So 3x plus 4y equals 18. X is 2. So 3 times 2 plus 4y equals 18. 3 times 2 is 6. Plus 4y equals 18. Left with that two-step equation, subtracting 6. 4y equals 18 minus 6. That is 12. And left with that one-step equation, dividing by 4. So y equals 3. 12 divided by 4 is 3. So my solution to this system is 2, 3. And that is my answer. We've solved this system of equations by substitution. Not substitution, elimination. All right, so let's tackle this problem right here. What is the first thing that we notice? Well, we notice that we don't have any of the same coefficients, or we don't have any opposite coefficients. So what are we going to do? Well, we have to make them opposite coefficients by multiplying both equations to give me opposite coefficients. So I want to look to see what common multiples I have. So right here, I have a 7 and a 5. So my common multiple would be 35 because both 7 and 5 have a multiple of 35. But right here I have a 12 and an 8. My least common multiple between these two would be 24. So I'm actually going to use my y values because I want just a smaller least common multiple. So I want to multiply each one of these equations to give me opposite coefficients of positive 24 and a negative 24. Because again, the least common multiple is 24. Okay? So we ask ourselves, what can we multiply by negative 12 to make it either positive or negative 24? All right. So I want to multiply the top here by a positive 2. Because if I multiply the top by a positive 2, that's going to give me a negative 24. All right. And I can multiply the bottom by 3. Well, if I multiply the bottom by 3, that still is going to give me a negative 24. I want a positive 24. So if I want it to be a positive 24, I'm going to multiply it by a negative 3. All right. So if I multiply the top by a positive 2, that's going to give me a negative 24. If I multiply this bottom equation by a negative 3, negative 3 times negative 8 will give me a positive 24, which is what I want, so I could eliminate those y values. All right, so let's go ahead and multiply through. 2 times 7. I'm just going to draw a line here to separate my work. 2 times 7, that gives us 14x. 2 times negative 12y is negative 24y. 2 times negative 22 is negative 44. All right, so I've multiplied that first equation. Now I'm going to multiply this second equation by negative 3. Negative 3 times 5x will give me a negative 15x. Negative 3 times negative 8, so a negative times a negative gives me a positive 24, which is what we want here, equals negative 3 times 14 is going to give me 42. All right, so negative 3 times negative 14 will give me a positive 42. And so remember, you have to multiply everything by what you're multiplying the equation by. All right, so now I can solve it vertically. This cancels out here. That's what we wanted. All right, 14x minus 15x, that's just negative 1x or just negative x, equals negative 44 plus 42, because it's positive. That gives me a negative 2. I still don't have my x value by itself. That's a negative 1. So I need to divide through by negative 1, because that's an understood negative 1. Now I'm left with negative 2 divided by negative 1. That gives me a positive 2. So we've solved this equation for x. A little bit more work. Now your last step is always the same. Whatever variable you're given, you want to plug it back into one of these equations to find your other values. So in this case, I have x. I want to find y. So I'm going to actually plug it into, again, it does not matter. You can plug it into your old equations or your new equation. I'm going to actually plug it into this one here. No, I'm going to choose this one because it has the smallest numbers. All right, make it easy on yourself. So I'm plugging it into my original 5x minus 8y. Again, it doesn't matter. I'm choosing this one, the original equation, because it just has the smallest numbers. All right, so I'm just plugging in my x value here to find my y value. So I've rewritten the equation, and I'm plugging in 2 for x. 5 times 2 minus 8y equals negative 14. 5 times 2 is 10. Minus 8y equals negative 14. Left with the two-step equation. Subtracting 10. Negative 8y equals negative 14 minus 10, that is negative 24. And then dividing through by negative 8. And negative 24 divided by negative 8 is a positive 3. So my x value is 2, my y value is 3. So my solution to this system of equations is 2, 3. So I have solved this system of equations. All right, so one last piece I wanted to show you is to learn how to check your work. You could do this mentally. I'm going to write it out, but whenever you do your systems of equations or when you're solving any equation, always go back and plug in your values to make sure your answer is correct. So for this last problem, I'm just going to plug in my answer 2, 3 to make sure that it checks out. All right, so I'm going to plug it into my original equation before I multiplied it. So x is 2, y is 3. And again, I'm just checking it. And you could do this mentally, but I'm going to write it out. So x is 2, y is 3. And let's see if it's going to equal negative 22. 7 times 2 is 14. Minus 12 times 3 is 36. Remember, you have to use order of operations. Multiply before you add or subtract. All right. And then 14 minus 36 does, in fact, give me negative 22. So that one checks out. All right. So let's try the second one. Space to separate my work. Plug in x for 5x minus 8y. So x is 2 minus 8 times 3. That's 10. 5 times 2 is 10. 8 times 3 is 24. Equals negative 14. 10 minus 24 is negative 14. And so that, in fact, does check out. All right. So we've solved 3 systems of equations using elimination. So hopefully you understood the lesson. Thank you for learning with me.